Cool. Okay, hello everyone. Today we are going to be looking at the AWS Global Infrastructure. Sorry. So by the end of this lesson, you should be able to define some various key terms we're going to look into, describe the components of the AWS Global Infrastructure, and summarize the benefits of the AWS Global Infrastructure. So let's start with definitions of some key terms. Now, the first one, high availability. So high availability is generally availability is this percentage of time that a workload is available for use, where available for use means that it performs its agreed function when required. So the aim is to ensure that an agreed level of operational performance. So with high availability, when a system fails, its components can be replaced as quickly as possible, often using automation. So the analogy I can give here is a car with a spare wheel. So when traveling, or in case if something happens to one of your wheels and you can't continue traveling, so it gets bad, you can't continue traveling. So the thing is, you have a spare wheel at the back of your back boot, for example, and you can just quickly change that wheel with the help of the spare wheel and continue going and continue traveling. So instead of waiting maybe for calling a particular service, maybe you're in the middle of nowhere and there's these services online which you can call for maybe someone to come and help change your tire. Or maybe, for example, if you have to maybe in the middle of nowhere and your wheel gets bad, then the next thing is, okay, if you didn't have that spare wheel, the next thing is, okay, you would have tried looking for somewhere to buy a wheel. So let's take the wheel as one of the components of your system that has failed. So, and yeah, the car itself as a system. So the main purpose of, one of the purposes of high availability is to maximize the system's online time. So our example we have of the wheel is like maximizing the time that you have to travel. The time that you're traveling and not like just standing, and minimizing any outages. So as I said, an analogy would be like having a spare wheel and the tools needed to replace one of your wheels that got bad when you're traveling. Now, the next one is fault tolerance. So it is a property that enables a system to continue operating properly, even in the event of failure of some of its components. So with fault tolerance, the system should continue to function properly even through failure. So an example can be plane. God forbid, okay, one of the engines have a problem, and if one of the engines have a problem, the plane should still continue flying properly and land without any issues. It shouldn't be in the case like your car when traveling with the wheel. If the wheel gets bad, you have to stop, change your wheel first before continue working. So with the plane, there's no time that, okay, you could stop in the middle of nowhere in the air and just start changing the wheels, one of the engine. So planes are designed in a way that they are highly fault tolerant. So let's maybe compare high availability and fault tolerance. What's very important to note is that with high availability, a minimal service interruption leads to a need for redundancy. And with fault tolerance, there is no service interruption. So going back to the plane, if there's an engine that's bad, so the plane should not have to stop in order for you to repair that engine, so that plane should still be able to land successfully, maybe at the nearest airport or so, without any problem with the system, the plane. But with with availability, there is some level of service interruption, but should be for a short period of time. It shouldn't be that long. Moreover, high availability is a combination of software and standardized hardware that minimizes downtime. And for this, going back to our example of a car, the wheel of a car, the spare wheel of the car, the spare wheel could be the hardware that will minimize the downtime. For example, if you didn't have the spare wheel, so you have to maybe go somewhere else and buy another new wheel, or having to call someone or a certain service to come and help you change that wheel. And if you're so far away from the main town, or it's going to take a lot of time. But with fault tolerant, it uses specialized hardware to detect faults and use redundancies as per need. So as I said earlier, with the engine, so even if one engine gets bad, the system automatically starts using the other 3 engines without your plane having to stop. And what I would say, like what I recognize is with high availability can be more costly, because take for example, you have going back to our analogy of the car, so you have a car with the 4 wheels, and you still have to have an extra wheel at the back of your car. So that's it for availability and fault tolerance. Let's go to disaster recovery. So this is basically a set of policies, tools, and procedures to enable the recovery or continuation of vital technology infrastructure as systems following a natural or human-induced disaster. So the question which he asks during before or after disaster recovery is what happens before and what happens after the disaster. We could use an example of an earthquake. Let's say you have a bank, and in this bank has surely, of course, its data center. And for example, there's an earthquake at the location of the data center. So the thing is, we need to think about how to maybe recover the vital technology infrastructure of this banking system, or how to enable our banking system to continue to be up and working, though there's an earthquake in that region. So that's it for disaster recovery. So now, latency. So it's defined as a measure of delay. So in network, latency measures the time it takes for some data to get to its destination across the network. And it's measured in milliseconds. A good example I can give here is, for example, sending an email to someone. Because, when you send an email, let's say, for example, at 10, you hit the send button at 10, then some milliseconds later, the other person the correspondent receives the email. So the time is so small that we hardly recognize it. Let's take an example where latency is high. That means there's a high delay. It's when you're maybe you're communicating with someone and you recognize that, okay, when you're having the call with someone, when you speak, it takes some seconds for the person to get what you've said and to respond. So that's when we have high latency. Now, another term is Ingress and Egress traffic. So basically, Ingress traffic is also traffic that enters the boundary of a network, as we see in the diagram by the side here. So it's traffic that enters the network. And egress is the traffic that exits an entity or a network boundary. So we have ingress and egress. These terms are very important to note, as we'll discover that as we're going along the course, we're going to be using these terms over and over again. At this point, are there any questions with what I previously, what we have covered up to now?
Yeah, I don't know, but when you started the global infrastructure, you talk about high availability for and those disaster stuff. I got lost. I didn't know, because maybe you were trying to maybe compare high availability services or this thing with fault tolerance. So I didn't know which one is which in terms of, were you giving us the disadvantages of high availability, or what happens when the system fails? And I don't know how I can put it, but can you just try to highlight through it maybe differences between this and how useful it is for us?
You mean like how useful will be high availability or fault tolerance?
Oh, what are they? Maybe I lost the introduction, but this, what are they? Are they just part of global infrastructure, or?
So what I'm just doing is I've just defined these terms.
Defining terms.
Yeah, just defining terms, and later on we are going to be using them not only with the global infrastructure, but later on along the course itself, you'll be seeing this term, maybe high availability, the one, a high availability solution, or they say, okay, using this service such way will give you high availability. Wouldn't go, just the main thing was just for you all to have the definitions at the back of your mind.
Okay, thank you.
And we are going to use it later on.
All right, thank you.
Welcome. Okay, anyone else with something? Question? Okay, if not, feel free to also ask your question in the chat. Maybe if you are going through a particular slide and the question pops in and you're afraid that you're going to forget, just put in the slide. I will look. There are also instructors looking at this chat as well. Okay, let's move to the global infrastructure itself. So, as you've been hearing the past 2 sessions, AWS stands for Amazon Web Services, and it's a public cloud provider. It has a global network of infrastructure to run and manage its own mini growing cloud services. And with the global infrastructure, it gives you the ability to deploy your applications workloads across the globe. So yeah, let's go here. So this diagram it's just mainly showing the regions. We're going to look at what regions are in AWS. But as I said previously, the global infrastructure, that's a global network of infrastructure. And this infrastructure, data centers, there's a network between them, so they are interconnected with one another. And I think we go to the next components of the AWS global infrastructure. We have regions, availability zones, edge locations, and point of presence. Now, we're going to dive into each of these components. First, next is what's a data center? So it's a facility, a building composed of networked computers, storage systems, and computing infrastructure that organizations use to assemble, process, and store large amounts of data. Yeah, there's also a very nice video here showing a data center. The best video I could have is that for Google, is just to give you an idea of how the data center looks how it looks inside. So you could check for other videos. And yeah, here it's like AWS data center, how it's looking like, how it looks like. There's also a link here for you to read more. But detailing on data centers, like because in data centers we have things like servers, and for you to understand that during the next class, our next class that's on compute, you understand more about servers virtualizations. But for now, just know that a data center is a facility. It has storage systems, for example, and it's used by organizations to store, process, and assemble large amounts of data. So an availability zone, also short form AZ. So basically, an availability zone contains of one or more discrete data centers or distinct data centers. So as we see in the diagrams by the side, we have availability zone A, it has 3 data centers, B, 2 data centers, C, 1 data center. So it has redundant power, networking, and connectivity in an AWS region. So that what it basically means is failure of electricity. Maybe it's the supplier, the electricity supplier. Maybe there's failure for that supplier to give us electricity on point A. So there would be another supplier on point B that's going to give electricity. It's not like in AO, where when AO doesn't supply electricity, I mean, the whole place is dark. I mean, the whole area is dark. That's what we have with availability zones or AZs. So each AZ has an inexpensive, low latency network connectivity to the other AZ in the same region. And it's best practice to design your application, or maybe to design a solution with two AZs. Now, traffic spanning availability zones has additional charges for egress traffic. So yeah, if you want to like outgoing traffic, we learned the definition of egress. So yeah, answering to your question, Napoleon. So bit by bit, we are going to be looking at these terms again, and we are going to see in various topics, these terms are going to be coming up. Okay. So let's take, for example, single availability zone here. This could mean that maybe in your availability zone, there's only one data center. So what happens if there's an earthquake, for example, or any natural disaster, and this data center is not like, maybe it destroys the network connectivity. So if maybe you have data that's stored or your application that's running only on the servers in this data center, so you have no recovery or failover when that disaster happens. So there's no high availability for instances. Again, there's no failover in a single data center. So this what now, in case if you have multiple availability zones, yeah, you have availability zones with two or more data centers. You have better high availability. Designing the applications hosted across AZs provide high availability options, HA availability. An example is Elastic Cloud Compute Autoscaling supports multiple AZs. Yeah, okay, compute, that will be looking into details next week, what's all about. But for now, yeah, the autoscaling option of EC2, also, yeah, the full name is Elastic Cloud Compute, supports multiple AZs. Yeah, this is another AWS service. Yeah, RDS, Relational Database Service, multi-AZ deployment supports also these multiple availability zones. And also Route 53. So, yeah, basically, I know it can be so, like, maybe the question is where this service is coming from. I know somehow, during the course, in the last two sessions, a PDF service was a PDF file was shared with the overview of all AWS services, so you could just have a look into it. But nevertheless, these services are going to be dealt into. We are going to deal with these services as we go along the way. And maybe after we look into it, then you're going to understand these points much more better. But just to have that in the back of your mind. So that's it for AWS availability zones. At this point, are we on a good footing? Am I fast? Or are there questions?
Yeah. So I was just wondering, how far are these data centers from one another in the multi-availability zones?
Sincerely, except if another instructor present has another answer, I would say the information on where the data centers are located, they are not, the information is not given, except if I'm wrong. Can somebody sound correct?
No, I'm just saying so because Yeah, he talks about the advantages of having multi-availability zones, because if you have one, maybe the natural disaster happens, we might not recover anything. So there must be a backup. So now in this diagram, I'm just seeing, okay, in zone A, so I'm seeing them together. So I was just imagining that if that earthquake happens, if they are closed, then it might destroy all. So that's why I'm asking that how distant apart are they, so that this cannot all cannot be destroyed.
Okay, I see this message from Yanku Banjika in the chat that yeah, an availability zone is one or more discrete data centers with redundant power network connectivity and in an AWS region. AZs are physically separated by a meaningful distance, many kilometers from any other, although all are within 100 kilometers of each other.
Yeah. Okay. It's clear now.
I have an example. I mean, in telecom, we have so many. We have about 6 or 7 availability zones in different parts of the continent. So that, if, for example, in Europe, we have like 2 ports. So when one of the ports goes down, traffic gets routed automatically to the other port, so that some countries don't lose connectivity in terms of their network. So what the company does is, when one of the countries is down, so they route all communication, all network to one of the ports that will support it for like a day or two until they fix the problem. As soon as they fix it back, the connection picks back together. So they just try to make sure that they are located not far from each other in terms of when they lose connectivity there, the other one can support for the meantime to reboot it.
Cool. Thank you so much for that example, Serge. Nice. Okay. Silence means no more questions and we are good to go.
I think I have a question.
Okay, silence, yes.
Something like some few months back, we experienced a certain situation whereby WhatsApp and Facebook was on shutdown for some hours. Is this the case? In this case, I don't understand. Is it like they don't have availability zones where they could transmit information from one point to another so that it could save, or what happens? Is it that all their shut down, all their servers were shut down, or what? I don't get it.
I think that would depend on what exactly the error was, what exactly the problem was. From my understanding, there was a problem with somehow DNS, but I didn't go deep into it to know exactly what, but the question is, what was the problem in question? Was it at the level of maybe a natural disaster that they did have to do with the data center? So the key thing is knowing what the problem was first.
Okay, so I'll have to research on what the problem was before.
Yeah, I'm not sure. Yeah,
okay.
Not sure it had to do with the data centers.
Okay, thank you.
Welcome. Okay, so AWS region. So yeah, each region is a geographical location, and AWS region consists of two or more isolated and physically separated AZs within a geographical area. So it's very important to know two or more. An AWS region consists of two or more AZs. An availability zone or AZ consists of one or more data center. So here are the diagrams. So this is an region A. You see it has two AZs, AZ A and B. region B, which could have 3 regions, A, B, and C. So currently there are 27 AWS regions. An example could be, okay, we have the Europe or Ireland region, the Frankfurt region, US West region. So maybe to make that, I could go to the console and show you all a little bit. Like, yeah, if the silence here, it's the management console, and you go here to the top. So you see these are various regions. Let's see Europe. You have the Frankfurt region, Ireland region. So Ireland region is EU West 1. So the availability zones will be EU S1, this A, B. I'm not sure if they C. But those how we identify the availability zones. In Europe, you have London. So in the US, we have the region Northern Virginia, Ohio, Northern California, Oregon. Africa, we have one in Cape Town, South Africa. So here are the various regions.
Hello?
Hello. Good morning.
Yeah, I
Hello.
get
Hello, maybe we start first from Larry Mustafa, then we come back to Auntie Judith. I think he was the first to speak out.
okay. Since there are many regions, for example, if you purchase a service from cloud, let's just say storage, and then you store your data in either in a region in South Africa. Will you, if there's a problem with the data center in South Africa, will you lose all your data, or you will have to store them, or when you buy the services, for example, the storage, they'll automatically share your data in all the regions, or you are the one to still go further by buying resources in all the regions?
Firstly, I would say the probability is very low that the whole region has an outage. Because remember, a region is made up of 2 or more data centers. It's not like it's one data center. So that's it's very important to note there. It's not like, yeah, your AZ, in which an AZ is made up of 1 more data center. So you can have one AZ, an AZ with 1 data center, but on the contrary, regions, it should be at least 2 regions, 2 AZs. And remember that each of these AZ has a data center, for example.
Okay. What you are saying is that in a region, they share your data in all the AZs around.
Not all the AZs.
At least 2 or 3.
Yeah, but it's definitely not all the AZs.
Okay, yeah. Because when you store from what I was reading previously, it shows that your data is stored in the cloud in either 2 or more servers, so that to avoid this fault tolerance in case there is a damage or a natural disaster, as you were saying before, in a server,
yeah,
backup in another one.
Exactly, that could be the case. Maybe this it could be in one data, yeah, the servers, one server in one data center, and that server in another data center, for example. Yeah, but that's definitely right, the point you're bringing for tolerance. You see, you're bringing those definitions of those terms we used earlier on.
Okay, I'm clarifying.
Cool. Nice. Okay.
Hello, Nyuyyu. Can I, good morning, everyone. Can I just come in a bit?
Sure, please.
Okay. So I mean, like as you just said, so when you're designing your application or whatever you're trying to do, you always think of, someone mentioned fault tolerance. But I mean, for some services, you, of course, maybe they can withstand in one availability zone, that if it goes down, it will still be okay. But there is always that advice that you have in the back of your mind, that when you're designing your architecture, you should think of such situations. And as you mentioned, if there are situations, depending again on what you are designing, that you think like, okay, I should think of, if I have it in this region, what if something happens in this region? Then you think of, should I really have a backup in another region, right? So again, those are things that will be coming up as you go along. You need to think of that situation. How do I design my application to be fault tolerant? So you either have it in two availability zones, at least two availability zones, or you have it in two regions, depending on the service, right? So you have to think of that. And as Nyuyyu said, and someone also mentioned, fault tolerance is something, it's a principle that you think while you're designing your application. There are so many principles, but that's one of them. So you think of having it in two regions, having it in two availability zones, but there are still some applications that will withstand one region, but rarely. You are always advised to think of having it in two availability zones or two regions, sorry. So yeah.
Cool.
Okay.
Yeah, thanks for chipping that in, Antivero. And you from the chat, there's also that if an entire region goes down, you lose all the data. You can, however, also configure replications that your data is also replicated to other regions. Yeah, and from Auntie Yolande, think of backups as copies of your data to fall back to in case of failure. Exactly. Then another reason why you could maybe want to deploy your applications in another region could also be because of your customers. I mean, the reach of your customers. Maybe you have customers in South Africa, you have some in Europe, so it makes sense to have your application, deploy your application both in a region in Europe and a region in South Africa.
Hello.
Oh, hello.
Yeah, I think, it's true that it's important to have backups and stuff. And in the beginning, maybe I got it wrong, but one of the reasons we get to go to cloud is for security and stuff like that, because if I have to store it or keep it, and then I need to do maintenance and other things which are costly, that's why I'm running to cloud. So should something like that happens where maybe the whole region goes down, and the suggestion from Sister Vero is, okay, you can put it in two more regions. And I know that putting in one region, you pay for that space, that storage space. So if I'm putting in two regions, that's why I need to pay. That is double, right? And that is costly. So I was thinking that is there not a possibility for maybe Amazon with these services, like, okay, by pay for one, I'm paying for security. So can they not migrate it and then have a backup for me somewhere, so that if one region disappears or completely get damaged, and then they can actually provide that to me? Or do I have to do that myself?
You need to do it yourself. Remember, the AWS takes care of everything of the cloud, and you who is working in the cloud, you need to design your applications having that in mind. They cannot just automatically say you move your thing to another region. Like you said, there is cost involved, right? So when you're thinking of, if I move it to another, if I have it in another region, of course I need to pay. So am I able to pay? That kind of thing. they have provided the architecture to the infrastructure to you. You can use it while you are in the cloud. You have to control what you're using in the cloud.
Okay. Yeah. All right. Thank you.
Yeah. Just to add again, Napoleon. So as your question being, why is it that because of security, if you were to upload your data, then AWS should automatically take care. You don't have to be bothered, right? And so just bear in mind that you are the one. So for some people, they may just need, depending on the kind of application they have, one region may just be enough, and it's true. You pointed the issue of if you use another region, it's expensive. That's also very true, because when you do disaster recovery, when you pick another region to do backups, you pay for that extra one, and it depends on the kind of business you are running. Even though it's expensive, then maybe you are running a kind of business that you really want that if something was to happen in one region, your services should still remain online. And because it's a crucial business, and there are many companies who are able to pay for that, so it's not like the cost is so astronomical that it's very difficult to pay. So there are actually companies that choose two regions. It's expensive, but then it meets the requirements that they need of high availability. And as Yolanda rightly shows on chat, there are critical businesses, and you come to see some of those examples. Yeah. So.
Okay.
Yeah. Okay. Good.
Just a quick question: is there a situation where any region or any AZ have lost data of any organization?
Definitely, there are. So remember one thing. I remember the definitions, right? We have a data center, right? And from a data center, you move to an AZ, where an AZ is a collection of one or more, data centers, right? So so it always depends. The lowest thing you can pick is a zone. And remember, we say a zone can be one or more data centers, right? A zone there is one or more data centers. So if you're using a zone that has just one availability zone, and then AWS will always let you know, you come to see that when you discuss storage and S3. So if you pick a zone that has just one data center, then you yourself, know very well that you are taking a risk, because AWS has informed you or has let you know that if that data center goes down, so for example, like in America, you have tornadoes, or in some areas where you have many earthquakes. So if something happens to that particular zone, then you, of course, lose all that data. And then if you move to an availability zone that have two data centers, for example, then what AWS, if you choose to deploy an application in availability zone that has at least two data centers, and you always know that when you are doing that. So what AWS will do is it will try to ensure that your data is stored, in that availability zone, because there are two and at times maybe three data centers. AWS will try to distribute your data stored across those three data centers, so that if you have a problem in one data center, AWS gives you how will I call it? Gives you that confidence that in the other two data centers you'll still be able to retrieve that data. So so that's answering your question. And then if there is a particular case where that has happened, unfortunately I don't have an example where maybe if that has happened till date, maybe it has existed, but that's something to look into. Yeah. We're just trying to give that background of you as a customer. You have to be sure when you are picking, you know very well where you are placing your own stuff. Yeah.
Okay, thank you very much.
Kennedy has the hand up there.
Yeah, sure, Kennedy.
Okay, assuming a region has 4 availability zones, you pay for your data to be stored in all these 4 zones, and unfortunately, everything goes down, will AWS take responsibility?
That's a question that I don't know. Maybe the other people can come up because I would say yes. But I stand corrected.
No, just to say, okay, let me come in there. So as I indicated, right, if you choose one region, right, the question is, does AWS take responsibility? So that's another thing, right? You have picked one region and AWS will guarantee you that, if something happens to, remember a region contains 2 or more availability zones. So for example, we have Cape Town, it's a whole region. So it means there are 2 availability or 2 or more availability zones in Cape Town. But imagine an earthquake comes and wipe away all that place. Then you as a customer, you equally knew very well that you have stored your data in only one region. So that was the risk also you took. And then that's why AWS also gives that possibility of what you have called replication, right? So you could design your system to be able to run in such a way that data is maybe not backup, so that maybe not just using Cape Town, it's being replicated to say a region in Europe, so that if an earthquake happened and took away the region in South Africa, then you have a backup in Europe that you can continue to run your systems. So AWS here won't be taking responsibility in my view, because for you as a customer, you know very well that you picked one region, and if that entire region goes down, of course it's bad business for AWS, right? But you as a customer, you know very well that you took a risk by choosing only one region. So if you think that you want to be very secure, then you have to pick another region, right? But always remember that, as we say, a region is very large, and the possibility for a whole region to go down, that has not happened, right? Because if that is the case, it means like a whole region could be, you see regions are made up of Frankfurt, Ireland, that means the whole of that region goes. Data centers do fail, but that is not a very big problem, or you see fires happen in data centers, but that's always easily recovered, especially if you have an availability zones with 2 or more data centers. Yeah, so in this case, I don't think AWS will take the responsibility. You as the customer, in your design, you choose one region. That would be, yeah, definitely what I would say.
Cool, like the interaction going on. So let me round up with regions. Let's continue. Yeah. So AWS services are not typically replicated across regions unless customers choose to do the setup and the replication. Yeah, that's as we were discussing, this came up as well. So traffic sent across AWS regions faces additional charges for Ingress and Egress traffic. So point to be noted. Yeah, if you have traffic across your application, you're sending traffic across the region, so you're going to be charged extra for that charge for the egress and ingress traffic. And here, we could even go to the link. So it's to look at the various AWS regions and AZs. Okay. So that one, you could look at it later on. Okay, the next question is, yeah, there are various questions you need to think when, or keep in mind when selecting a region. So where do you operate? I mean, where are you deploying your application? Where are your customers? Are they in South Africa? Are they in US? Are they somewhere in Europe? And where are you allowed to operate? So the first thing is you have to think about compliance and data governance and legal requirements. So depending on your company and location, you might need to run your data out of specific areas. An example is let's say an health insurance company here in Germany, of course, is working with data for German citizens. They could say that, okay, the restriction that you have that's supposed to be in place is that the data shouldn't be stored in anywhere outside the European Union. So that means in mind that you have to select a region, either in Ireland, the Ireland region, the Frankfurt region. Yeah, and selecting a region in, for example, US West region, that will be against the compliance requirements. So another thing to keep in mind is the proximity to your customers. It will make a little bit no sense if you have your application deployed in if your customers are in South Africa and you deploy your application somewhere in the Asia region. So doing like that would increase the latency, would lead to high latency for your customers to start receiving the content. So it's going to be the time it takes for your customer to receive the content will be so much slow. Maybe another better example is if your customers are in Europe and you go and deploy your application somewhere in the US. So it's better to deploy the application in another European region than to take it that far. Then you also think about available services within a region. So there are over 200 AWS services, but some of these services that are not available within particular regions. So when deploying your application, think about that as well. Or when selecting a region, think about that. You also have to think about cost. An example could be maybe there are some areas in which a company can find the tax structure in particular regions much more favorable than other regions. So that's something important to keep in mind. Yeah, basically here it's a summary of the three components we have seen so far. Region, let's start. The two components at the moment. We started from a data center. An availability zone contains one or more data centers. A region contains two or more availability zones. Yeah. This is kind of an example architecture. Here we have instances, EC2 instances, also Elastic Compute Cloud. No worries, we're going to look into it next week. It's our instructor and Tibero that will lead that discussion. So you could launch these EC2 instances in this availability zone US1A, and could launch another one in US1B. And we see these availability zones are found in the region US East 1. Okay, so that's it for the main two components. I see at this point there's a question, Yembe.
Yes, thank you for this opportunity. Hi all. I just wish to clarify a doubt on concluding the AWS regions. You did mention the charges on Ingress and Egress traffic. So I wish to know, are both traffics paid for?
Yes. So I think that's correct. Yeah, traffic sent across AWS regions face additional charges. So if your main being there's traffic from, you're sending traffic from your application in the region Frankfurt to the one in Ireland, you need to pay for that. There'll be those additional charges, you pay for it.
Okay. Okay, that's what I
Traffic
want.
going out or in the region, yeah.
Sorry.
Because just to clarify, because looking at the overview, I felt Brother Ban said the information coming into the center are not being paid into the network, are not paid for, and those leaving are being paid for. So I want to know the difference between this egress and ingress and those.
Okay. I didn't get that point of.
I think she's.
Come back, yeah, and yeah, he's.
I think we actually had the same worry, because I think she's trying to say, because I think like in module 1, or was it in the introduction, it was stated that data moving out of the cloud is not paid for, and data moving into the cloud is not paid for. Or is this one being, is this ingress and egress being paid for because it's between the regions, or it's not moving out of the cloud? I think that's the question.
Yeah. Let me come back to it. I think the example I gave was when you load data into, I was giving the example of storage, right? So when you are uploading a file from your computer to say to S3 storage, I gave an example of storage, you come across that. When you are doing that upload, you know, you don't, so that's data moving into the cloud, you don't pay for it. Right, so let's say I'm uploading data to an S3 storage bucket, which you will learn later. You don't pay for it. But if I want to download that file later, I'll pay for it. But this other case that Nyuyyu has given is completely different. It is if you have data sitting in, let's say, Europe, in a region here in Europe, and you have another region in South Africa. So if you have data, maybe the way you have designed your architecture, and it requires that at times data will travel from a European Union region to a region in South Africa, what you will do is you will pay for that traffic that is leaving the European Union, and then you also and going to South Africa, and just like so, the traffic that goes. That's the in and out traffic, right? You pay for it. So there are some charges that AWS will put for you because you are moving data out of the out of the European Union. Remember, when you have data sitting in the European Union, it's stored on some data centers, and then you have AWS have a global network that connects the region in Europe to the region in South Africa. So you pay for the traffic, that traffic that is leaving the European Union. And then if you have data leaving the South African region to come to the European Union, so data that is leaving out, so it's going out, right? You also pay for it. So that's what this example that Nyuyyu is given is different here. It's talking about data traveling between the regions. But the example I gave was if I as a customer, if I just sit and I'm uploading traffic, right? Because this is different. Then in this case, it's the regions that AWS is managing. So they will charge you when you move data from one region to another, in or out. I don't know if you get that. Okay.
Yeah.
Okay, good.
So please, so uploading your data from your on-premises to cloud, is it not called Ingress, or is it? Okay, it's not Ingress, right?
Yeah, data. Yeah, so data moving into the cloud, right? Yeah, that's correct. It's correct, but the whole point is you as a customer are doing that upload. But in the other case, the traffic is moving between AWS regions. So when you are moving, initially when you are moving the data as a customer, it's just coming from a customer location, right? Which at that time is not an AWS, the AWS doesn't consider it its own location. I think, can please, if you mute, if you are not talking so much, echo. Thank you. So when I'm reading as a customer, right, it is coming, AWS it's not an AWS location, it's not an AWS region. It is the customers, say on premises, he's uploading from his own premises, say, or maybe it's just fine to an AWS region. So that upload is from a complete different angle. But then the one that Nyuyyu talks here is when you are moving, when it's moving between AWS regions.
So it's a two-way traffic that you have to pay for.
Yes, in the AWS regions, yeah, the in and out, right?
Okay.
Yeah. Okay, good.
Cool. Nice. So we were here, the summary. Okay, so going to the other component of the global infrastructure, point of presence. So the point of presence consists of edge locations and regional edge caches. So with this, it makes sure that we have delivery of content with low latency, low delay, with minimal delay. They are about 410. There are more than 410 points of presence, as this comprises of more than 400 edge locations and 13 regional edge caches. Now, the next question is, what's an edge location? So you can describe it as mini data center directly connected to AWS using high-speed private network links. So an edge location, it's used by an Amazon Cloud Front. That's one of the AWS services. So this is used to store cache copies of your content closer to your customers for faster delivery. An example could be maybe a Netflix movie. Let's say, the Netflix, you're in Europe, for example, and the Netflix movie, maybe it's, let's say, stored in some region in Asia, for example. So the first customer that tries to access it in Europe, for example, it can take a little bit of time for the content to reach. Now, after that, when that first customer uses that content or watch the movie, so that movie will be cached in an edge location. So a copy of that movie will be cached in an edge location. So when the second customer tries to access the movie, it will not be sent again, right? It will not have to take a time again for the movie to load right from the Asia region. So it's already cached within the Europe region. So it just gets a little bit faster. So this time happens maybe in milliseconds, microseconds, we hardly recognize it, but that's the principle of what edge locations help us do here, especially when using with Amazon Cloud Front. So edge locations are located in most of major cities around the world and specifically used for CloudFront. CloudFront is known as a content delivery network, to distribute content to end users, to reduce latency. This service CloudFront, we're still going to look into it in the next courses. So this way, I'm just kind of giving kind of high level overview. So edge locations are content distribution services. The further the data is located from the user, the slower the transfer and thus the higher the latency. So with edge locations, we try to reduce this transfer time and reducing the latency as well. Okay, so that leads us to point of presence. As we heard, point of presence, it's made up of the edge location, and we hear edge location is a mini data center, for example. So here it's like your user wants to have content, or it's trying to get content. It could be maybe a user you're using your laptop, your smartphone, or in a particular office. So Here you just have the summary of all the components of the global infrastructure. You have the points of presence, then you have the data center, before availability zones. Yeah, availability zones, one or more data center. Then we have the regions, which is made up of 2 more availability zones. Okay, yeah, here's more on points of presence. So now we look at services at the edge. So you have CloudFront, catches your static and dynamic content. We have Route 53 that delivers your request from the closest edge location. WAF filters incoming public traffic at the edge. So these are mainly services that would use the edge locations. We'll go a little bit deep into this. We'll start from CloudFront. So it's a content delivery network that securely delivers videos and applications to customers globally. So this is done with high transfer speeds in a developer-friendly environment. So we have Route 53. This is a highly available and scalable cloud domain name system, known as CNS web service. Then last but not the least, we have the Web Application Firewall, abbreviated as WAF. So Web Application Firewall helps protect the web application against web exploits. Could be against attacks such as SQL injections and cross-site scripting. All of these, this basically just to show you that there are applications that use so services at the edge. When we go into the security module, each of these services are going to be dealt with. So you hear more about them. Okay, while we're speaking about the global infrastructure, we have looked at the components of the global infrastructure. Now, the next thing is, what is the advantage of AWS global infrastructure? We have the first one on security. So all data flowing across AWS global network that interconnects the data center and the regions is automatically encrypted at the physical layer before it leaves the secured facilities. So availability. So each region is fully isolated and comprised of multiple AZs, which are fully isolated partitions of AWS infrastructure. So this makes AWS highly available. So you also have performance. The AWS global infrastructure is built for performance. Yeah, AWS regions offer low latency, low packet loss, and high overall network quality. We also have flexibility. Yeah, gives you the flexibility of choosing where and how you want to run your workloads. Yeah, you could choose, and when do you, and yeah, you choose if you want to use the same network control plane with various AWS services. Now, scalability. The AWS global infrastructure enables companies to be extremely flexible and take advantage of the concept of infinite scalability of the cloud. So it could be, okay, I've seen something. Okay, so scaling application, maybe at some point you want, for example, with an EC2 instance, at some point you want one instance, for example, you can increase and have more instances or more servers, virtual servers. I think going to EC2 is a little bit going ahead because it's difficult to understand now unless you do the compute, which you're going to deal with it next week with compute virtual servers. But let's go to the last but not the least benefit. It has a global footprint. So we have seen AWS has various regions across the world. So it helps you deploy your applications in minutes across the globe. So here there's a link here in which you can read more about the benefits of the AWS Global infrastructure. So that's basically it for the AWS Global infrastructure. If you have questions, before I ask my own questions, feel free to jump in if you have questions. Okay. Then silence means everything okay or nothing okay at all. Okay, so let's go in the questions. Maybe I'll have some noise then.